Okay, we're going to go through these GCSE questions on electricity, and I'll show you the way you should set out your answers. Okay, so I'm going to go through it by reading through it first. So it says figure 1 shows a mobile phone with its battery removed. Here's the battery. A student measured the potential difference, so they want you to understand how you would read this question. So the key words are potential difference. The student measured the potential difference across the battery and then put the battery into the phone. You have to decide what is the equation linking current, potential difference, which is V, and resistance R. So you've got to just know the equations. This is a knowledge question. So the only correct combination is V equals IR. Okay, that's the only correct response. So that's a very simple 1-mark question, and that's what you've got to do. So V equals IR is the only way to get the first mark. The question continues. They're now giving you the current. So the current is, it says 0.12 amps. So I like to put I equals 1.12 amps. They then tell you the voltage is 3.9 volts. So you've got to use the correct equation to calculate the resistance. So obviously if you put the wrong equation down before, you're unlikely to get this part right. So if you want to work out the resistance and you change the subject to the equation, resistance is voltage divided by current. So you need to not only remember the equations for this exam, you also need to know how to rearrange them. So remember again, I is for current. So you divide the 3.9 volts by the 0.12 amps, and you should get an answer of 32.5 ohms. They've already given you the units, so it's 1 mark for getting the equation the right way around, 1 mark for putting the correct numbers in, and 1 mark for the answer. Okay, they would accept 33 as well because you've only got 2 significant figures in the data given. The next part of the question, again, they want you to write down the equation that links energy, E, so they're telling you energy is E, power, P, and time, T. So because they've defined each letter, you can put it just in simple terms. That'd be energy equals power times time. Okay, because remember, power is the rate of transfer of energy. So if you multiply by the time, you'll get back to energy. Energy is in joules, power is in watts, and time is in seconds. That's something you need to remember. So this is 5 marks for this first 2 pages. Now these questions can be in any exam board, so they're not in particular for any board. Okay, so the average here, it says the battery was fully charged, yeah, when it was put in the phone. The battery then discharged when it was switched on. Over time, the battery is discharged. The average power, it says, as it discharged was 0.46 watts. So that's the power. They're telling you P is 0.46 watts. And then it says the time taken, so here's the time taken to fully discharge was 2,500 minutes. Well, that's the time. But remember, time should be in seconds. So they want to see if you can work out the time in seconds. So 2,500 minutes in seconds would be 2,500 times 60. So if you manage to get that, that's 1 mark just for converting it. If you fail to do that, and you multiply the power, which is 0.46 as given above, by whatever time you leave it in minutes, they will give you some marks, okay? But to get all 3 marks, you need to convert it, work it out in seconds, multiply the power by the 150,000, which is 2,500 times 60, and you'll get the answer rounded up, would be around 69,000 joules. Okay, so that, I think it automatically will come out to that if you do it in your calculator. So you get 3 marks, 1 for the seconds, 1 for multiplying the seconds by the power, and 1 for putting the right answer down in the answer box. Okay, then it says the mobile phone includes a sensor, yeah, to monitor the temperature. Okay, and they're using this component as the sensor for a component. So this is the circuit symbol, and they want you to recognize what this circuit symbol is. What component does the circuit symbol represent? The answer is, and the only answer you can put, is a thermistor. Okay, so you need to know that term. This looks a bit like a spatula. Okay, you just need to know your symbols. It then says, for part F, the temperature of this component, the thermistor, increases. Well, they want to know that you understand that when the thermistor temperature increases, what happens? It says the potential difference remains constant, so voltage doesn't change. That's a controlled variable, if you like, if it was an experiment. And then they want to explain what happens to the current if in the component. Well, if the temperature goes up, you need to know that resistance will go down. As long as you put it in writing, that the resistance goes down. I'm just putting it in symbols right now, but you should write it out in full. Then the current will increase as a result. Okay? So that's basically what they want you to be able to do. And that's how you get the 2 marks here. Okay, over the page. It's now a 13 amp plug. They want you to find out what's wrong with the wiring. It's not wired correctly. They want you to work out, well, the blue should be the neutral. Yes, I didn't photocopy this in color, unfortunately. It would have shown it in blue. So the blue wire they've put to the earth pin, and the neutral wire they put the green and yellow wire there. Okay, so they've labeled everything. So the blue wire should be to the neutral, and the green and yellow should be connected to the earth pin. So if you say swap the wires around, the blue wire with the green and yellow, as long as they show you understand both sides need to be changed, you can't just say half the answer. You'll get the 1 mark. Okay? Then it says the correctly wired plug, once they've corrected the mistakes, connects the washing machine to the mains supply. Okay, so they want you to know about the mains electricity supply. That's for the UK. So they say give the potential difference. Here they want you to give what the potential difference is, and they want you for the main supply in the UK, and they want you to give the frequency as well. You need to know this. Okay, well, the potential difference is about 230. I would accept 220 to 240 because that's what I teach, and different people quote different values. And the mains frequency is 50 hertz. That's the same in most countries. So Europe, the United Arab Emirates, where I am, and you might be taking this paper, it's also 230 volts and 50 hertz. The washing machine is switched on. What is the potential difference between the neutral wire? Well, the neutral wire is always at 0 volts, and the earth wire. And the earth wire is always at 0 volts. So the difference between them is 0 volts. And be careful, because some people, and initially I misread the question. I thought they wanted to say the difference between a neutral wire and the live wire. Well, the live wire would be 230 volts more than these two, but both of these are kept at 0 volts. So that's easy to misread that question. So again, read the question very carefully, word for word. Okay, then it says the plug has a fuse. Okay, remember where the fuse is in the plug? So that's the one on the live pin. You always put the fuse on the live wire for safety. It wants you to just draw the symbol for a fuse. That's it. Well, you need to know your symbols. We draw it. It looks like a resistor with a line going through it. You get 1 mark. It then says the washing machine has a metal case. Okay, so if it's got a metal case, it could be dangerous if something goes wrong. It says a fault causes the live wire to make contact, to make an electrical connection with the metal case. Yeah? So if it's made contact with the metal case in effect is also live. So it's at 230 volts. And then it says the earth wire has not been connected. So if the earth wire is not connected to the metal case, then explain why it would not be safe for a person to touch it. So if the metal case is touching the live wire, the metal case is also live and it's dangerous. So it says the person could, or would, I would say, get an electric shock. So 1 mark is for saying that you would get an electric shock. and then say explain why. So you've got to explain why they would get a shock. As the metal case, this is how I put it, as the metal case is now live or at a high voltage, there is a potential difference across the person. So if someone touches it, they're also touching the ground, presumably. So they're touching the case, which is 230 volts, yeah? And then they're also touching the ground. Their feet are probably on the ground. There'll be a potential difference from high voltage to somewhere where it's not a high voltage. That could give you the second of the 2 marks, yeah? You could also word it this way. So the person would provide a connection to earth and the current would flow through the person, okay? So that's how you could, either of these second ways of explaining it would give you the second mark. But the first one should be that you would get an electric shock if you touched it because it was live. Okay. They then said the earth wire is now connected. So if you've corrected it correctly to the metal case, yeah, then it shouldn't be the same problem. Explain why it would now be safe. It would now be safe for a person to touch the metal case, even if the live wire touches the metal case. Well, if the live wire now touches the metal case, the charge or current would flow through the earth wire, yeah? And you could say instead of the person, yeah? So it would go through the earth wire. So it's not wanting to highlight it properly, so I'm going to just partially highlight it so it doesn't highlight the next bit. So what? So if it goes through the earth wire, it won't go through the person, it will do something else. Because the earth wire has a very low resistance, so the earth wire has a very low resistance, yeah, what would it do? It would blow the fuse, yeah? So because of this, it would blow the fuse. So you need to say that this would basically deactivate the circuit and it would no longer be live. So you need to add a little bit more detail to get the second mark. Most of the students I saw were only getting the first mark and weren't clear enough to get the second mark. Okay, the next question is an experiment on varying the voltage of this battery using this variable resistor in series with a filament bulb. Okay, and I always do this experiment with students and I make them plot the graph, so they should be familiar with this. The potential difference usually goes on the x-axis and the current then, which is a dependent variable, goes on the y-axis. It then says, why is the component labeled J included in this circuit? Well, if you didn't have it in the circuit, you just have a constant voltage. You wouldn't be able to vary the voltage, okay? It will always give you the full value of the battery. So you need it to adjust the voltage across the circuit, yeah, to adjust the voltage. That's why you need it, okay? So this, if you make this a high resistance, this one will get less current. Therefore, it will get less voltage. So it shares the voltage with the bulb. Remember, the ammeter is there to measure the current. But the independent variable is voltage, so you really need to say it's to adjust the voltage. This is the independent variable, and then you measure the current. Okay, so one of my students said put to adjust the current, which is technically correct, but you should say it to vary the voltage. Okay, and then the next bit says, well, the resistance of the bulb increases as the potential difference across the bulb increases. That's why it curves. Okay, so as the potential difference increases, the current can't keep up at the same rate, so it's not a directly proportional curve, a line, it's a curve. So that means if you double the voltage, it doesn't double the current. Okay, so they want you to explain why. Well, as the voltage increases, V goes up, that means the current also goes up, the power gets higher, so you're putting more power into the bulb, so it gets hotter. So that's one mark, it gets hotter. You don't need to put anything else, but they would accept it because the resistance, so R goes up, because the atom is in the metal, the atoms in the metal start vibrating more, and this impedes the motion of the free electrons which are trying to go through it. This would be an alternative to just simply saying it gets hotter. Because it gets hotter, it's got more resistance, okay? So that's what they want you to know, is that the filament actually gets hotter, and that's what high resistance is due to. Lattice vibrations. The next bit says the bulb is at full brightness when it's got 12 volts. Yeah, so that's the full operating voltage is 12 volts. Okay? At that value, the current becomes 3 amps. Yeah? So when it's working at its full capacity, it's a 12 volt bulb, obviously, you multiply the two and it works out the power is voltage times current. So again, you get 1 mark just for remembering the equations. So you really do need to remember all your equations. 12 times 3 becomes 36, and this time you get a mark for the units because they haven't given to you. You could put watts, or you could put joules per second, because watts is actually joules per second. Okay? Joules per second. You need to put both if you don't put watts. So those are a combination of units you could use. Okay, in the next question, I haven't put my answer down, but I'm going to explain to you. In this question, it says, you will be assessed on using good English, organizing information clearly. Yeah, so it's about clarity and use of good communication, and using specialist terms where appropriate. So the table, it says, gives data about 2 types of bulb people may use in their homes. So you can have the type of bulb is here. So 2 types of bulb, halogen or LED. So these are the 2 they want you to compare. Light emitting diode is also called an LED for short. Okay, they're giving you information on the efficiency of each bulb, the cost of each bulb, and the average lifetime in hours. So they're giving you 3 bits of data, and they want you to evaluate it. So it says evaluate in terms of cost and energy efficiency. So cost we've talked about, energy efficiency we talked about, the use of the 2 types of bulb, okay, of the light bulbs. So to gain full marks, you must compare both types of light bulb and conclude. So you must compare both types of light bulb. That's your job, to evaluate it to gain full marks, and make a conclusion as to which light bulb would be advisable to use or would be best to use, given all the information above. Now, I didn't write anything, okay, because there is no set answer to it, but I'll show you the mark scheme. So obviously over here we can see that the LED is more efficient, so it converts the electricity into light more efficiently, but it costs about £12, £2, 6 times more. But then you see you get 18 times more life out of it. So it lasts 18 times, 36 divided by 2, forget the thousands because they cancel out. It's 18 times longer lasting. Okay, so is that worth it? Yes, you got to make these comments in a clear fashion. Okay, one of my students, I think he deserves full marks. I haven't finished marking it, but that's how you get the 6 marks. Well, this is what the mark scheme explains to you. If you've made no relevant comment, obviously you get 0 marks for no relevant comment. If you give a level 1 answer, so a basic answer, you've made a basic comparison of either cost or efficiency, you'll get 1 or 2 marks. Level 2 is 3 to 4 marks. So to get 3 to 4 marks, there is a clear comparison. So we're looking for clarity. This is basic, and here is a clear comparison. So again, of the same differentiating factors, the cost or the energy efficiency. And finally, or a basic comparison of both cost and energy. So it's a basic, but you've done both, you deserve 3 or 4 marks, okay? So it's up to the examiners to read your question and read your answer and decide how much you deserve, okay? And then for the 5 to 6 mark answers, which is what they're calling the level 3, there is a detailed comparison of both the cost and the energy efficiency. So this time goes from basic to clear to detailed comparison. So again, it's looking at the both. For full marks, yes, to get full marks, the comparison made should be detailed, should support, the detailed answer should support a conclusion. In other words, your conclusion is based on your detailed comparison as to which is preferable. Okay, so if I was looking at the data, I would choose the LED, and I'd explain what my reasoning would be having looked at the data that's been provided. So the quality of your answers, things you could say, if we go to the examples of points made by students, halogen is cheaper. Yeah, that's a basic comparison. Simply giving cost figures is insufficient. Yeah, you need to actually make comparison between two. Halogen lights bulbs are cheaper to buy. 6 halogen lamps would cost the same as 1 LED. These are kind of comments you could make. LEDs last longer. So you can have a look through all these and read them and then decide how you would answer it if you could make it into sentences. So it's about clarity. So it says 18 halogens would cost £35. So as long as you've done some thinking and shown that you've done some thinking, the teacher will decide whether you deserve 1, 2, 3, 4, 5, or 6. Okay, and then it's got energy efficiency. So the comparison would be LED is 22% more efficient. Okay, so this is just giving you some sample answers that you could put in. Okay, so that's why I haven't put my own answers in there. It's just down to the person who's marking your paper. Okay, question 4 is next. So question 4 is in a circuit depends on the potential difference, it says. The current in a circuit depends on the potential difference V. So I, remember, is current. V, and it says, which is the potential difference is provided by the cells, so I put that in brackets, and the total resistance, so RT, the total resistance of the circuit. Figure 1 shows a graph of current against potential difference for a component. Well, if you've already done a question before, you should recognize this graph is the same as the previous one you did, so you should be able to work out straight away that this is a filament bulb, because again, when the voltage goes up, the current tries to go up. Initially it goes up in equal steps, and then it starts to lag behind, so the curve goes down a bit. So the resistance increases as the bulb gets hotter with higher voltage. So you need to recognize the shapes of the components when you change the voltage across them. And then it says figure 2 shows a circuit containing a 6-volt battery drawn here. It says 2 resistors X and Y, yeah, are in parallel. Well, you can see they're in parallel because there's a junction here where 2 amps goes this way. Well, you can work out straight away that 1 amp must go through the other way, and then they join up again. Okay? They want you to know the circuit rules. So in a parallel circuit, what is the potential difference across X? Well, since there are parallel circuits, each resistor is in parallel, is connected directly with the 6-volt battery. So each of the 2 paths will also be at 6 volts. So that's just knowledge. You need to know your circuit rules. That's how you go to get your 1 mark. Okay? So X and Y are both at 6 volts. So then you know that if you calculate the resistance of X, yeah, which is the one we were just looking at, and it's the one that had 2 amps across it. So it's 2 amps going across X, 2 amps, and it's 6 volts. So they just want you to see if you can work out the resistance of X. So the resistance of X is the voltage of X, which is 6, divided by the current going through it, which is given by the circuit, 2 amps. 6 divided by 2, the answer will be 3 ohms. If you've made a mistake in the earlier part, they will allow your error to be carried forward, and as long as you've used the correct equation, they will give you the 2 marks, 1 for the answer and 1 for the correct calculation in the equation. They then want you to work out what I said before. What is the current in Y? Well, if 2 amps went one way, then 1 amp is left for the current in Y, because there's 3 amps in total. You don't lose any current. Then it says calculate the resistance of Y. Well, we just said that there's 6 volts. So 6 volts, the current is I. So you do the same equation, but instead this time is 6 divided by 1. So it means Y has a bigger resistance, which is why it gets less current. The bigger resistor will get smaller current going through it. And if you notice, both will multiply to 6 volts. Okay, again, they will allow your error to be carried forward if you made an error earlier on, but you're using the correct method. Okay, it then says when the temperature of X increases, yeah, remember it says resistor, its resistance increases. It's a normal resistor. A normal resistor means you increase the temperature, the resistance goes up. Okay, temperature goes up, resistance goes up. What would happen to the potential difference across X? Okay, well, the potential difference hasn't changed because you haven't changed the battery. So the potential difference across X stays the same. But the current yeah? Because the resistance is increased, the current will then decrease. If the resistance goes up, the voltage hasn't changed, that means the current must go down to keep the voltage the same. And of course, if the current has decreased, then the total current in the circuit will also decrease, okay? Because you have a higher resistance path, so it will take less current, okay? So that's how you get those 3 marks. And then I think this may be the last question. Let me just double check. Do we have 2 more? Because if we have 2 more, okay, we have 1 more for the first section. So the next one says the diagram shows a circuit set up by a student. Okay, so it's a circuit you've seen before, but instead of it being a filament lamp, over here is a resistor. So again, my class they did both circuits. So this is the circuit set up. Though when we did it, we did use a variable power supply, which has its own control of the voltage. But if you don't, and this is a common circuit you need to be aware of, if you've got a 6-volt battery, you put a variable resistor in it, you can adjust the variable resistor to give a different voltage across the resistor that you're investigating. Okay? The student comes up with the following hypothesis. So you need to know what a hypothesis means, okay, and you need to be able to refer to it when you're concluding what happens. It says the current through a resistor is directly proportional to the potential difference across it. Okay? So, for an ohmic conductor, like a resistor, that is in fact true. So you're going to find out. So if the hypothesis is correct, what should the student predict will happen to the current when the potential difference doubles? Well, if the potential difference doubles and it is directly proportional, and I'm already giving you the answer that it is, if that's what directly proportional means. If you double the independent variable, which in this case is the potential difference, so if you double the potential difference, then the dependent variable, yeah, which is the current also doubles, okay? It would double. That's how you do it. So they want you to see, they're testing to see if you know what directly proportional means. Name the component in the circuit used to change the potential difference. So the component in the circuit to change the potential difference across the resistor you're investigating is what I said, it's this component, and they want you to say, this is how you change the voltage here. Okay? So that's called a variable resistor. So it's a copy, it's a question you had before when you're doing the filament lamp. Okay? The next bit, it says, here's the data. So they're giving you these points, yeah, and you can, it's a directly proportional, or they're telling you that the hypothesis is directly proportional. And when you look at these results, they're pretty much in a straight line, apart from one which doesn't fit the other pattern. So they're telling you that's anomalous. Okay, you need to know what the meaning of that word is. It means one that doesn't fit the rest of the data. It's a bit too far away off the line. The other two, there's a couple of data points which don't fit exactly on the line or are not touching the line. Okay, and it's my line of best fit. I drew this, so this wasn't in the question. That's one of the questions. It says, why has the student plotted the points for a line graph? Why have they used a line graph and not a bar chart? Well, you wouldn't use a bar chart for something that can continuously vary. You can have any value of potential difference. Whenever you have any value, yeah, you will always do a line graph. So you've got to say variables are continuous. Yeah, you can have any value of voltage, any value of current. Okay, so they're not discrete variables. Discrete variables means like one is black, one is green, one is blue, one is red. If it's that, then you would use a bar chart. Usually in physics, we don't tend to use bar charts. Most of our graphs are line graphs. So then they could be a straight line or they could be a curve. So then you need to know about continuous and discrete variables. So the next part says, one of the points has been identified as being anomalous. Well, we talked about that already. Yeah. What is the most likely cause? The most likely cause, not any cause, the most likely cause for this anomalous point. Well, the voltage is pretty much going up 1 volt each time. That means you're going up. That's pretty accurate. That you're choosing to take the voltage up each time. So it's unlikely going to be an error in the reading of the voltage. So the most likely error will be that you've misread the ammeter. Okay, that will be the most thing, the misreading of the ammeter. Okay, my highlighter pen doesn't want to go across all of my handwritten text, but that's the point I wanted to make. And then it says draw a line of best fit. Okay, for these points, because it's a resistor, you should know that resistor will be a straight line, and the points look like they're a straight line. Yeah, you shouldn't try to make this into a curve. You need to know that a fixed resistor has a straight line proportionality function. Okay, so if you draw a line of best fit and it's gone through the points, never join the dots in physics. And then it says, does the data the student obtained support the hypothesis? Well, you would say yes, it does support the hypothesis, but the answer, you won't get 1 mark for just saying yes. You've got to give a reason for your answer. So what's the reason? You need to show this mathematically using the data from your graph. Example, you could say at 2 volts, the current is such and such. So you read up from the graph, what is the current at 2 volts? So if you look at the current at 2 volts, it's about halfway between 0.2 at 2 volts, it's this one. It's exactly halfway, not this anomalous point, not the point that fits. You actually use the line, and it's exactly halfway between 0.2 and 0.3, 0.2 and 0.4. So you would say at 2 volts is 0.3. At 4 volts, the line is 0.6. So you've doubled the voltage, and you put the values in from the graph. So you draw 2 lines. You draw a line there and a line here with a ruler, and you put what it was, and do the same at this. And again, you use this line. The line is the average of all your points. That's what the straight line graph means. And you'll see it's 0.6. So it goes from 0.3 to 0.6. The voltage doubled and the current doubled at those 2 corresponding points. So you say at 2 volts, the current is 0.3 amps. At 4 volts, the current is 0.6 amps. And this shows that it is justifying and supporting the hypothesis. One doubles, the other doubles. Remember, that was a hypothesis. That was a prediction. So that's the numerical prediction. Now, the next question is from the static electricity part of the course, which if you're doing an IGCSE syllabus in the international GCSE syllabus, for example, you do not need to do this section. So this is only for people doing the full course in IGCSE. That means not doing double award, they're doing triple award. So here it says a student rubbed a plastic rod with cloth. Okay, my students always get amazed. By doing that, you can actually bend flowing tap water coming out of a tap. So you rubbed a plastic rod with a cloth. It tells you the rod became negatively charged. Okay, that means the cloth must have become positively charged. Okay, it says explain why the cloth became positively charged. Well, if the rod became negatively charged, it means electrons have been transferred from the cloth to the rod, from the cloth. Again, my highlighter doesn't want to accurately go over my text. So you've got to say from the cloth to the rod. Okay? As long as you say from the cloth, they realize that you know the answer. And since electrons are negative, that means now the cloth has more positive charges than negative. So that's what they want you to do. They want you to say the cloth has more positive charges in total than negative. So again, that shows you understand that transfer of electrons is the only way. That's how you get the 3 marks. And then it says figure 1 shows the negatively charged rod is put on a balance. Okay, and it's reading 100.25. Okay, they then bring another charged rod close to it. Hold it close to the first rod, which is on the balance, and you notice it goes from 100.25 to 100.35. It says explain why the reading increases. Well, both rods have the same negative charge. It says another charged rod. Well, we're assuming they've both been charged in the same way. Okay, both rods have the same, in this case, negative charge. Okay, because both rods have the same charge, same charge, they repel each other. Both are negative. They both repel each other. So that means there is an additional force downwards. Yeah, it's trying to push the other rod away, and that's what increases the reading on the balance. Clever, huh? So it's an electric field force which pushes down the rod and appears to make it read greater on the force meter or the mass meter. Okay? It says the balance had a zero error. Yeah? So in other words, when you started reading it, there must have been, before you put the thing on, the rod on it, it wasn't reading exactly zero. So it has a zero, what's called a zero error. And it says the zero error is not important in this experiment. Can you give a reason why? Why is it not important? Because the question actually says they're only looking at the change in the reading being measured. So it doesn't matter what the initial reading was before the rod went on there. You're just seeing that it had a change, and it wouldn't have made a difference if it didn't start at zero. Okay? I hope that makes sense to you. Then the final part is a negatively charged rod is now held near an earth conductor. So the conductor is touching the earth, and it says, explain why a spark jumps between the negatively charged rod and the earth conductor. Well, that means there must be a pretty high potential difference between the two, yeah? Between the two objects. Well, so the Van der Graaf generator is basically what we show our students, and the Van der Graaf generator will have a large potential difference between a charged area and a neutral earthed conductor. So, but in this case, they're just saying, well, it's the same theory holds. If there is a potential difference, this could cause electrons or charges to move through the air. That's the only way you can get a spark, is if the charges can move through the air. As therefore it will move, because the rod is negatively charged, the electrons are the only thing that can be transferred. They would move to the earth's conductor. Okay, now whether that's likely to happen or not doesn't really matter. You've got to show that you can do the correct thinking in terms of physics. Well, I hope you found that useful. I'm going to put this up on the YouTube channel so you can have a look at it at your own leisure and to make your corrections in your exam where you went wrong, and to make sure that your communication skills improve. So if you found this video useful, make sure you like it, share it with your friends who may be struggling with the same kind of questions, and subscribe, and then next time you do a video you'll be able to get notified, and it will help you prepare for your GCSE exam. Thank you, and hopefully see you next time. Bye.